many of you know about angular momentum? Okay, see, something is moving like this. If its mass is m, if its velocity is v, then linear momentum p is equal to what? mv. Okay, so this is what is linear momentum. Linear momentum. So is moving like this. Now a linear momentum. If we are looking from here, if this distance is r, then angular momentum L is equal to r, that is in the cross product toward a direction. How to find the direction of cross product? Okay, take this one for the first term. Suppose Tangam, you are Bharat, you are Jaron. Okay, Bharat cross Jaron. Okay, B cross J. Then this is Bharat. Keep Bharat vector in this direction. Curl the fingers in the direction of Jaron. Okay, clear? So that is what? B cross J. B cross J. Here R cross P. R cross P. So what will be the direction? Inside. Okay. This is actually rotational effect of linear momentum. Rotational effect of linear momentum. Say for example, if this door is there. Suppose, yeah, this is full water. Okay, right. Okay, just see this. Now if I apply here, this is having rotational effect. This is not moving, this is trying to rotate. Notice or what? If you do this, this is having anti-clockwise motion. For me this is going to be anti-clockwise motion. When I apply here also, this is anti-clockwise motion. Here also anti-clockwise motion. If I apply here, now what is happening? This is moving, linear motion. So where I am applying the force, based on that, this is having rotational effect, this is having linear effect also. When linear effect is happening, someone will be really affected if he really touch their heart, right? Okay, correct or what? If you capture their heart, he will be just stunned, correct or what? Idhe mari, the heart of the mass is nothing but center of mass. If we are really pointing at mass, this will be under control, will go linear motion. Other places, if we apply force, what will happen? Rotational effect will happen. Okay, just like this. If I apply force here, nothing is happening. Okay, I need rotational effect for this. So when I tried with the center of mass, it was dealing is difficult. But other side, tuck, it is closing. Same way, what is this rotational effect of force is what? Torque is equal to R cross F. R cross F. So for all the rotational effect of bala, R cross bala. Rotational effect of prabha, R cross prabha. Rotational effect of force, R cross F torque. Rotational effect of momentum, R cross P. Okay, R cross P generally. So that is the reason. So if something is making circular motion, if this is the center, in straight direction what will be there? P is equal to mv also will be there. Its angular momentum will be what? Rotational effect of this linear momentum or what? Okay, so from the center. With respect to center, if you are taking this radius, this radius is nothing but r vector. So this is r cross p, r cross p. So this is nothing but rp sin theta. What is theta? The angle between r and p. What is the angle between r and p here? 90 degree. Always what? The radius will be radius and tangent will be what? 90 degree. So we can say that rp sin 90. So the angular momentum L is nothing but rp, or we can write L is equal to mvr. Nothing wrong, no? Once if we remove cross and if we put sign or for dot product cos, then direction is not a big deal. Clear? So this is what is angular momentum. Clear? R cross P. L is equal to R cross P. All are comfortable with cross product, dot product and all, right? Clear? So shall I erase this? Those who don't know the basics of this, you can note it down. These things in detail will come in. Is orbital angular momentum. Integral multiple of orbital angular momentum will be the stable orbit. So this guy is nothing but L is equal to NH by 2 pi. You understood, no? Clear or what? Shall I erase this part, basic part? Okay. Erase panna kudadana, just to give me an indication, okay? Okay. So I can write this L is equal to what? L is nothing but R cross P. L is nothing but R cross P, and this is nothing but magnitude of R, magnitude of E into sin theta in circular motion. This is radius vector. What is the direction of velocity at that particular instant? Direction of velocity in circular motion. Tangential, always tangential. Correct, no? Okay. So this is how it is going to be. So 90 degree. So I can P or RMB. So generally MVR we used to say, if you want you can say like that, MVR is equal to NH by 2 pi. NH by 2 pi. Remember this also. MVR is equal to NH by 2 pi. Clear? Suppose if they ask the relation between linear momentum and any other values, okay, linear momentum, if they ask specifically linear momentum, what we can take? MV is equal to NH by 2 pi r, NH by 2 pi r. Correct or what? Okay, so this is what is linear momentum is equal to NH by 2 pi r. We can write like this also. Okay, so H by 2 pi is a constant. H by 2 pi is a constant. This n can change, no? Number of orbits. Electron jumped, n will change. Electron jumped back, number will change. Electron jumped, radius will change. Electron jumped back, radius will change, or what? So we can write in this way: P is equal to H by 2 pi into n by r. So calculate H by 2 pi and keep it ready. Whenever you want, throw it and get the answer. 6.624 into 10 raised to minus 34 divide by 2 into 3.14. Just calculate it, note it on the corner. And every time just do that. Okay, h by 2 pi, these kind of things. 1 by 4 pi epsilon 0, already we have 9 into 10 raised to 9, same way. Clear or what? Right. So I will need this equation, just mark it as equation 1. Okay, keep it like that. Okay, now the same thing is also called Bohr's quantization condition. Same thing is also called Bohr's quantization condition. Okay, this, but Bohr's quantization, Bohr's quantization condition. Quantized means what? Quantization of charge, no? Q is equal to Ne. N is 1 2 3 4 5. It cannot be ara electron, mukka electron, we cannot say, na? Correct. Integral multiple means nothing but quantization, means N should be 1 2 3. Correct or what? Clear? That is one thing. Now what we will do is, we will calculate radius, velocity, kinetic energy, potential energy, everything. Okay, so simple, everything simple. All those big formulas will become small formulas when we convert all these constant values. We will remove all these constant values and we will convert. So calculation of radius r. Okay, so for that what we can do, Rutherford's model, right? For Rutherford's model, what it is, this force between nucleus and electron will be utilized as centripetal force. This, who gave this model? Rutherford. So Fe to Fc. So what I'm going to see is about, suppose if this is nucleus and if this is electron, okay, electron is moving, and suppose this is nth orbit, and this distance is what is radius. So we the charge of nucleus. So this is E divided by R B. So this we can write R, no? R is equal to R. Thing is, okay, so we have another formula, right? That also we will do. Okay, let's leave like this: Q1 Q2 divided by R square and R square. Another formula is there also, no? MVR is equal to NH by 2 pi. So that we will square. Okay, so this is one equation. This is one equation. Another equation is MVR, no? MVR is equal to NH by 2 pi. MVR to NH by 2 pi. Why we are doing this? We don't want this V here. V will become a variable. Okay. So M will NH. This was equation 1. We can do this as equation 2. So squaring 1, we by 4 pi. Okay, so divide 1 square by 2. Then what we are getting? Divide 1 square by 2. Correct or what? Suppose if I do 1 square divide by 2, I will be getting m square v square r square divide by, this side we will take m v square divide by r square. Correct? Yes. This is going to be n square h square divided by 4 pi square, and this side divide by 1 by 4 pi epsilon naught q1 q2 divided by r square. Okay, so what I am getting, this r square will be r. Okay, so let this be here, r will be cancelled out, this will become r. Then this v square can be cancelled, this m cancelled. Correct or what? Okay, so now this, correct or what? Okay, so mr square is equal to finally will be, this will go up 4 pi epsilon naught n square h square divided by 4 pi square, and this q1 q2 also will go here, right? q1 q2. Clear? Okay, so this 4 will be cancelled off, this pi square will be cancelled off. Anywhere something is extra is there, please tell me. Okay, so finally mr square is equal to epsilon naught n square h square, here pi, and this q1 is going to be ze and q2 is going to be just e. So what will become r? Okay, here this r and this r also will be cancelled off, this r also will go up, so this r, this square will be cancelled off, this is going to be mr. So r is going to be epsilon naught h square n square divided by mass will come here m pi z e square. Anything is missed or not? Is it correct? Correct or what? Okay, so the formula for radius is equal to h square epsilon naught divided by, in the right form, in the exact form, if we write pi m e square, and this is n square, this is going to be z. Okay, okay, so this is the radius, this is the radius. You need not worry, okay, need not by heart this. Okay, so this is the formula of radius. In this h is constant, so r is equal to h square epsilon naught n square divided by pi m e square z. So that is also constant, h is also constant, epsilon naught is also constant, pi is also constant. So everything we will substitute, finally you will be getting a simple value for radius is equal to 0.529 will come, will take 53 into n square by z. This understanding is important. Suppose what you will do if they ask directly here. directly like this. If they ask, if your basics are strong, okay, no problem. I am just giving you the step just because what is involved here, we must have a clarity. Okay, so this is very simple. So what we need to remember, 0.53 n square by z electron volt. Electron volt. So this value of constants we have put in order to get this in, sorry, not electron volt, Armstrong. Okay, and here n is nothing but the number of shell or orbit, and z is atomic number. Okay, clear? Easy, no? Nothing is there. Orbital momentum, mvr is equal to nh by 2 pi, square it. Divide this with the centripetal force. Okay, then arranging, that's it. Okay, continuous discussion is done, just because if someone asks question based on this, you should be comfortable. Something which we do not know, definitely will become uncomfortable. New person coming to the class will be uncomfortable, right? Someone familiar means we are comfortable, same thing. Continuous discussions of this thing will make us comfortable. Clear or what? Shall I erase this? Completed? Okay. 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 Now calculation of radius is done. Okay. V. Calculation of velocity. Okay. Now we will do that. So R is equal to 0.53 n square by z. Okay, if it is hydrogen, this is going to be simply 0.53 Armstrong will come. Second orbit of hydrogen, this into 2. Third orbit of hydrogen into 3. That's it. Okay, only that much. Clear? Okay, so fine, that's enough. Okay, now we have a formula, orbital angular momentum. Today's session you will never forget this. Orbital angular momentum is what, Tangams? nh by 2 pi, Rajas and Ranis. So radius hanginga podalama, that we can put here with your permission. mv into what? h square epsilon naught divided by pi m e square z. n square கொடுத்து வச்சிருக்கோம் உங்களை மாதிரி ஸ்டூடெண்ட்ஸ் கிடைக்கிறதுக்கு. such கரெக்ட்டா இங்க இருந்து v இங்க என்னெல்லாம் கேன்சல் பண்ணலாம்? பை ஒரு அது ஒரு சந்தோஷம். that step we need not அதுதான் நிம்மதி. ஓகே, கேன்சல் இது கேன்சல் பண்ண முடியாதா? ஓ, இது ஆஹா ஃபார்முலா அது கிடைக்குமா? ஓகே, v is equal to now என்ன? e square z by 2h epsilon naught n. அவ்வளவுதானா? புரியுது? கரெக்ட் தானே? ஓகே, so this is a formula of velocity. Done. Okay, right? So here velocity is equal to e square is constant, okay, 2 is constant, h is constant, epsilon naught is constant. So solving all this, finally we will be getting 2.18. Okay, that you can write it as 2.2 also nowadays, into 10 raised to 6 meter per second. So this is the velocity into 1 z by n into z by meter per second is the velocity. Okay, number 1 is this one. Number 2, which you need to remember, is 2.18 into 10 raised to 6 z by n meter per second. Clear? Velocity is done. Okay, Papa, happy? Okay, உங்களுக்கு ஏதோ மனவலி இருக்கிற மாதிரி பக்கத்தில் இருக்கிற பாப்பா did something to you. Should I handle? No. Okay, fine. Baby, are you able to follow? பிறந்த சின்ன baby with vision he is coming. Okay, good. Okay, clear children? Okay, so velocity is done. Velocity is done. Suppose if we get velocity, then what will be the next temptation? Kinetic energy. Next one is kinetic energy. So kinetic energy, அது உலகத்தில் எங்க பண்ணல என்னது? Half m v square. So half into m into v square is what? So this one. Okay, e raised to 4 into z square divided by 4 h square epsilon naught square n square. Okay, so this is what is kinetic energy. Okay, half m e raised to 4 z square by 4 h square epsilon naught square into n square. Clear? Okay, so here if we put it in a standard form, kinetic energy is nothing but m e raised to 4 z square divided by 8 h square epsilon naught square n square. So in this, mass of electron e raised to 4 8 h square epsilon naught square, all these are constants. All these are constants. So putting the value of all that, finally we will be getting kinetic energy is equal to 13.5 electron volt. Correct or what? Finally we will be getting 13.5 electron volt. Clear? What all should be there? Z n square so should be there. Okay, in third, like this. Third point, kinetic energy is equal to 13.6 actually 13.6 z square by n square electron volt. Done. Okay, kinetic energy is done. Okay, clear? What is potential energy? Potential energy okay, so the formula for kinetic energy, let it be there. What is that? Formula for kinetic energy is how much? M e raised to 4 okay z raised to z square divided by 8 h square epsilon naught square n square. This is kinetic energy. It will be there. What is electrostatic potential energy? Q1 Q2. What is this? Is going to be 1 by 4 pi epsilon naught. Q1 is going to be ze, Q2 is going to be e, divide by what? R. So potential energy is going to be z e square divided by 4 pi epsilon naught into R. So what is R? R is what? Radius, right? So if we put that value, also, this is going to be into what is R? H square epsilon naught pi m E square. Correct then? This much. Okay, so this will go up. Finally we will be getting here one thing is there, here this is minus, right? My charge is minus, so minus will be there. Okay, right, now what we will write? Minus m, pi will be cancelled off, so minus m, this will go up, this will become z e raised to 4 z square divide by 4 x square epsilon square, and then correct, m e raised to 4 z square. You should involve with me, otherwise you will sleep. Okay, just do it in such a way that you are deriving all this. Actually you are already deriving, so just involvement is should be there, otherwise you will be sleepy. So is it correct or what, children? Right, correct or what? What I am going to do is, so this is potential energy, or we can say this is nothing but U. Okay, so U is equal to kinetic energy is here, kinetic energy is here. Now the same formula, minus m e raised to 4 z square divided by 4 h square epsilon naught square into n square, and divide with 2, I will be getting potential energy as minus 2 into m e raised to 4 z square divided by 8 h square epsilon naught square n square. Okay, so what is this? This is kinetic energy. So directly we can say that the potential energy will be 2 minus of 2 times kinetic energy. So when you get question, you can easily do things on that and get the answer. So this is kinetic energy, means again no need to study another figure, no need to study this is like a 27.2, no need to study like that. What you need to do? Minus 2 into 13.6 into z square by n square electron volt, bus over. Okay, so here what is also done? Potential energy is also done. Clear? Okay, what about total energy? Total energy will be what? Potential energy plus kinetic energy, we can say. Okay, so what is U? And all these m e raised to 4h by pi, all these things, if you do like it, you will be getting the same thing. So instead of minus 2k plus k, minus k, so total energy is going to be, formula wise, this is going to be like a minus m e raised to 4 z square divided by 8 h square epsilon naught square n square and over. So here total energy is going to be minus 13.6 into z square by n square electron volt, or we could say minus of kinetic energy. Okay, over, done. Everything is done. Children, this formula. Summary. Okay, so radius is equal to 0.53 into n square by z, Armstrong. Okay, so there n is what? The number of orbit. First ground state, n is equal to 1. Okay, z is atomic number, velocity is 2.18 into 10 raised to 6 into z by n, kinetic energy is 13.6 into z square by n square electron volt, potential energy is 2 into minus 2 into kinetic energy. Remember only that kinetic energy value. Remember only that kinetic energy value. Potential energy is minus 2 into kinetic energy. Total energy is what? Minus of kinetic energy. Done. As easy as that. To remove an electron, should we give energy or we should receive energy? Receiver. Give. Correct or what? Suppose if you shoot with a photon shooter, what will happen? Photon will go knock the electron out. So giving the energy, if we give the energy, generally if we give the energy, that is positive, right? When we give something, when we are giving, that is nothing but positive. So you can see here, total energy is what? Negative. Total energy you can see as negative. Total energy is negative. So this is nothing but, this is the binding energy, that is electron is kept there by nucleus. Okay, so this is actually the force of attraction. Force of attraction. In Coulomb's law also, in electrostatic force also, you have seen if negative comes, what is that? Attraction. Attraction. So that is the force with which it is kept the electron intact. Okay, just like this is electron, and if this is nucleus, it is kept like this. Okay, but this one is moving, that is no problem. Okay, but it is kept like this. It is just like a thread is there. You are moving around me. Keep on moving like this. Correct or what? Okay, if necessary, I will pull you. But what you are doing with the energy, you will be maintaining like this, and you will be moving circular motion. So that since I am kept you with me, that is called the binding energy. Binding means you have seen a bond. Such a strong bond those two friends have. Tell no, correct or what? So that is what is bond. This is called bond binding energy. This is also called what? Binding energy. This is also called binding energy. To knock the electron out, what we have to give? We have to give energy. We have to give energy, which is nothing but what? Positive energy will have to give. Correct or what? Okay, so this binding energy, which is nothing but minus 13.6 into what? Z square by n square electron volt. This is the energy which nucleus keep the electrons. Okay, now see, these are all in electron volts, right? These are all in electron volts. So we may get questions in joule also, right? We may get the questions in joule also. So remember that value also, so that we need not waste time for calculating. So I could say total energy is equal to minus 2.18 into 10 raised to 18. Okay, minus 18 Z square by n square joule. Okay, minus 2.18 into 10 raised to minus 18 Z square by n square joule. All these answers are in electron volt. Suppose if you to convert into joule, what we should do? This one 1.6 into 10 raised to minus 19 வச்சுட்டு add பண்ணியா போதுமா? multiply பண்ணணுமா or divide பண்ணணுமா? multiply. Okay, just do that and verify whether you are getting this answer. Okay, do that and verify whether you are getting this answer. Clear? So if you know what the questions related to that, you can solve easily. So shall we do some problems quickly? Okay, right. Find the kinetic energy of an electron in the second orbit. Okay, one question number. Okay, kinetic energy of electron in second orbit of lithium plus. Come on. An electron volt. Okay, got right? So kinetic energy is equal to 13.6 into Z square by N square electron volt. What is the atomic number of lithium? Energy of the second orbit means N is equal to, so this is 13.6 into 9 divided by 4 electron volt. So calculate. Anyone got the answer? 30.66. Leah, is it correct? This is how getting 31.
13.6.
30 now.
13.6.
Okay, done. Clear. Another one. So what is the total energy of this? Total energy is nothing but minus of kinetic energy. So this is nothing but minus 30.6 electron volt. What about potential energy? Minus of 2 into, yes, so 61.2 electron volt. Bas everything will get from this, right? Next one is what is the kinetic energy of, kinetic energy of electron of hydrogen atom in the first excited state? Kinetic energy of a hydrogen atom in the first excited state. 3.4. So kinetic energy is 13.6 into Z square by N square. So 13.6 into hydrogen atom, atomic number is 1. So what is N? N is equal to 2. So first shell, that is N is equal to 1. This is actually called ground state. So first excited state is the N is equal to 2. So this is the first one when it is excited state. So okay, so first excited state. Okay, So this is how much? 3.4 electron volt. 4 electron volt. Clear? So likewise, second excited state, third excited state, all these things we can do easily, right? Fine. So can you tell me what is the energy in the second excited state also? Same thing. Second excited state and third excited state. So I am not calculating. You calculate it correctly and tell me the answer. So hydrogen atom is equal to, what is the energy, kinetic energy? 13.6 electron volt. Okay, hydrogen atom, first excited state is N is equal to 2. What is K? 3.4 electron volt. Hydrogen atom, N is equal to 3, that is second excited state. What is kinetic energy? 1.51 electron volt. Okay, now one more. N is equal to 4, what will come? 0.85 electron volt. Okay, right. Now the thing is, this data, suppose if you draw energy level diagram. Okay, energy level diagram. Say this is N is equal to 1. N is equal to 1. This is the energy. So next is total, that is kinetic energy. So next state will be what? N is equal to 2. N is equal to 2. So what is the energy of this? Minus 3.4 electron volt. What is the difference between this? Can you tell me? How much? 10.2. Now what we are going to do is, let us take N is equal to 3. What is this? 1.5 volt. Please tell me these two. 1.89 electron volt. This was 10.2. This is 1.89. Okay. Now see. Now N is equal to 4. Ever papas and puppies? Minus 0. Dear Tangams, what is the difference between the 0.6? One more digit. Okay, I am believing you. 0.6. As we go up, the phenomenon is like the energy difference is coming down. Energy difference is coming down. So next will be, we are not going to calculate, but what is this? This will be lesser than that. N is equal to 5. Again, further if we go down, this is going to be N is equal to 6. Then it will be very close. So when you get N is equal to infinity, this is going to be continuously coming like this. That will become, energy will become 0. Okay, just like this. So this is the diagram. Okay, so N is equal to infinity, continuous spectrums will be. Okay. Done? Okay, clear? Okay, so just I asked you some values, right? En2 minus En1. What was that calculated value? 10.2 electron volt. Correct? Same way, En3 minus En2. 1.89 electron volt. Now En4 minus En3. Correct appa? So this was the difference. Ellame negative thane. All are negative, means magnitude wise if we take, they are all negative values. The difference in total energy will be negative. The difference in kinetic energy will be positive. Difference in potential energy will be negative. Correct? So carefully do like. Now how many points we have written? Bohr model. Sixth one already we have to that. So sixth one is nothing while revolving in a higher orbit, while revolving in a higher energy level, in bracket, which is nothing but orbit. Okay, orbit may emit radiation. Electron may emit radiation okay, of a specific wavelength, and falls to, or we can say de-excites to a lower energy level. Okay, so it was running in an orbit. Okay, it will emit photons or radiation, then it will come down to lower energy level. So what specific wavelength? Specific wavelength energy of emitted hc by lambda. Okay, so this hc by lambda will be the difference of En2 minus En1. This N2 is nothing but higher orbit and N1 is nothing but lower orbit. Okay, suppose if it is jumping from second orbit to the first orbit, that is, suppose for example En2 is equal to 2 and N1 is equal to 1. So then hc by lambda is going to be the same formula we will be getting, En2 minus En1. Energy of the second orbit is, we can calculate by putting 13.6. okay, these are all total energy minus 13.6 into z square by n square we can put and we can calculate. Calculate like that for hydrogen atom, for the first down state is nothing but minus 13.6 only. So if you put minus 13.6 minus of next state is what? 3.5 electron volt minus of 3.5 electron volt. Do this, what we are getting? This value, right? Minus 10.2 electron will be getting. Okay, now if you want to know the lambda of the which is going to come, what you can do? Lambda is equal to Hc by minus 10.2 electron volt. That is why I said this h by 2 pi or Hc, these kind of values, if you remember, without wasting time you can do. If the option gives directly this, mark it. Okay, this is what is the next statement. The change in the energy, okay, change in the energy will be the energy of the photon emitted when it is de-excites. So that photon will have a specific wavelength which is nothing but the difference En2 minus En1. So Hc by lambda photon, Hc by lambda of the photon will be nothing but energy of the higher orbit minus energy of the lower orbit. Okay, clear?
En1 minus En2.
Okay, so En1 minus En2, this is going to be minus 3.5 minus of minus 13.6, 13.6. So what will be getting? 10.2 electron volt. Just look at the magnitude. Okay. Okay, clear? 10.2 electron volt difference. Clear. Okay, so next rule is next statement or next statement by Bohr model is while revolving in lower energy level, an electron may absorb of a specific jump or excites to a higher energy level. Higher energy level. Clear? Higher energy level, and the same thing. Hc by lambda is going to be change in the same thing. En minus En1, the difference will be same. Okay, in both the cases you can take En2 minus En1. Okay, difference will be, you know, one will be of higher orbit, means which will have more energy, lesser one will have less energy. Clear or what? Okay, so energy of such photon will be always energy of such photon. Actually, what is Hc by lambda? Energy of photon. Only energy can be equated to energy. Maximum work also can be equated, because correct or what? Joule, then unit will be joule. So this is something energy of what? Photon. Energy of photon. So energy of photon is nothing but energy of photon emitted or energy of photon absorbed is difference in the energy of two orbits. Okay, so mark that also. Okay, so what happens is an emission spectrum is there, absorption spectrum is there. See, if we pass a white light, suppose if this is a gas of this is gaseous atoms. Okay, we have kept gas is there. If from this side, if you are passing white light, so what kind of photons it will absorb, what kind of light it will take, which is equal to the difference of energies between the energy levels, only those they will absorb. So after that this white light will pass through this gas. Here we will get if we get some missing. Who has eaten that? They have eaten that. Okay, I threw a Toblerone. On the other side, Joshua sir caught. I threw a bounty. Joshua sir was looking like this. Nothing is coming. See, in between, someone of you caught it. You went to the other level. Then I threw a jalebi. Joshua sir caught. Then I threw a Mysore pa. Suddenly Mysore pa is missing. Joshua sir is searching. Then what happened? Cedric has gone to the other level. Okay. So Joshua sir plotted everything on the white screen. Toblerone. Bounty is missing. Jalebi. Mysore pa is missing. Okay. So this is what is absorption spectrum. Absorption spectrum and emission spectrum. Okay. This is how we identify Toblerone, bounty missing, jalebi, Mysore missing. Atom's name is Deva and Bu. Understood or what? Bounty is there, Toblerone is missing, jalebi is also missing, Mysore is also there. Okay, this atom is Pita. Likewise, we will categorize. So, just like our fingerprint, based on this pattern, they are what? Wavelengths. Wavelengths means colors. So, just like a rainbow. Different colors will be. Clear or what? Right. Drawbacks are there in Bohr model. He is only able to analyze about hydrogen-like species. Hydrogen-like species. 1 electron. That is why lithium plus plus also gave. In problem now, lithium plus plus gave. Lithium plus plus means 3 electrons were there. 2. So how many electrons are there? 1. He plus also you will get. Ask questions for this. They cannot give this sodium, chlorine and all for this one. It is not valid actually. Even if they set the question also, actually that is not conceptually correct. So lithium plus plus, hydrogen, helium plus. Okay, so this is suitable only for electron species. Okay, note it down. Drawbacks of Bohr atomic model is, okay, drawbacks of Bohr atomic model is suitable only for, okay, suitable, he could explain, rather than we say he could explain, okay, or it stands true only for, it stands true only for or we can say 1 electron species. One electron species. Okay. Then it has not considered wave nature of electron. Just like interference, diffraction, all these are wave nature, that is not discussed. That is one thing. Another thing is Heisenberg's uncertainty principle. No, what is that? Both position and momentum cannot be. Okay, but here we have written no position regarding radius, regarding velocity. We have written the formula, right? Correct, from Bohr model and from Rutherford's model. we have derived momentum. Momentum means momentum we will be getting. Velocity means momentum we will be getting. Radius also we have written. Radius means the position also will be getting. So here he has not considered Heisenberg's uncertainty principle. Okay, not considered Heisenberg's principle. So this is one point, one drawback. So position of electron is nothing but radius. Momentum of electron is through what? Velocity, mv, right? Then splitting of spectral lines, something like splitting of spectral lines are there. Electric field, magnetic field, spectral. He has not explained about that. Splitting of spectral lines is not. Stark effect and Zeeman effect. So all these things are solved by another model that we are not going to study that. Okay, that is in chemistry. We don't have that here to study. Okay, no. Quantum mechanical model is the latest one. That is that you have in chemistry, but in physics we will stop with the Bohr model. Okay. So what is the next one? He cannot see the splitting of light. Okay, right. So that is the Bohr atomic model. Okay, so Stark effect, Zeeman effect, all these things he did not explain. Now we need to see atomic spectrum. Okay, atomic spectrum. Okay, so we have seen Rutherford's model, then drawbacks of Rutherford model and Bohr model, and now the drawbacks of Bohr model. Now we need the atomic spectrum. Okay, different lines that you will see after the break. Okay, thank you.